have a look at the data analysis from our mass stoichiometry lab. So I'm going to work from the data file here in the lab. I'd encourage you to have a read through this background information. All right, basically what I'm going to be looking at is what do those coefficients in a balanced chemical equation really represent? What really are they? Okay, so I'm just going to hack that background info out. I'm also going to drop in the balanced equation from our lab. So we would normally be looking at this in terms of grade 10, and we would say 2 molecules or 2 formula units of silver nitrate react with 1 of barium chloride to produce 2 molecules or formula units of silver chloride and 1 formula unit of barium nitrate. Okay, I'm going to change this a little bit. I'm going to say, look at things we know. We know from the lab that 0.85 grams of silver nitrate is equal to 0.005 moles of silver nitrate, and 0.052 grams of barium chloride is equal to 0.0025 moles of barium chloride. Okay. If you actually carry out the calculations, this was number 3 on the analysis, you'll see that if I set this up as a ratio, 0.005 divided by 0.0025 is 2. That really means that there's 2 moles of silver nitrate for every 1 mole of barium chloride. So those coefficients in a balanced chemical equation, those aren't just molecules or atoms or formula units, those are moles. So we would say that for every 2 moles of silver nitrate in the process that we looked at in the lab, this requires 1 mole of barium chloride. Okay, so now that we've established that that's what we call a mole ratio, we're going to look at types of work that we can do with this. We can use this to solve more practical problems even. Okay. I can manipulate this. I can say that, well, 0.0050 moles of silver nitrate, I can convert this into moles of barium chloride. So this is just taking that relationship that I've written there in words and showing that I can apply the unit conversion dimensional analysis methodology to this. So 0.005 times 1 mole of barium chloride for every 2 moles of silver nitrate, and I get 0.0025 moles of barium chloride. Okay, you've already seen this. Remember, you've massed these values out, you converted them to moles, you know this works. All right, so can we measure moles directly? Not exactly. All right, there's no such thing as a molometer or a molometer or anything like that, but we do know we can measure mass. We use grams for that. Okay, these are what are known as mass problems. All right. So, what mass of silver nitrate is required to react with, let's say, 0.52 grams of barium chloride? So I'm going to use the quantities from the lab. Okay, 0.52 grams of barium chloride. All right, let's convert this to moles. All right, I'm going to look to use the mole ratio, but in order to use a mole ratio, I have to actually have both my quantities in moles rather than grams. So I'm going to convert barium chloride to moles of barium chloride using its molar mass. Then I'm going to apply the mole ratio of moles of silver nitrate, 2 moles of silver nitrate to 1 mole of barium chloride. Then I'm going to find the mass of silver nitrate, because remember the question asked for mass of silver nitrate. 169.88 grams of silver nitrate for 1 mole of silver nitrate, that's the molar mass of silver nitrate. I'm going to run through and I'm even going to look at my units, all right, because what really should happen is my units should all cancel here. So grams of barium chloride will eliminate grams of barium chloride. Moles of barium chloride will eliminate moles of barium chloride. Moles of silver nitrate is great, but can't appear in the answer, so those are eliminated as well. The only unit remaining is grams of silver nitrate. So at this point, it's simply a matter of calculator math. So look at that number. 0.85 grams of silver nitrate, which we already know to be true. This is what you did in the lab yesterday. Okay, you may have to go back and watch this a few times. All right, recommend pause it, try some of the problems if necessary. Okay, keep coming back to it.